Hello everyone, welcome to my YouTube channel Maths is Magic, and we were talking about Ceva's theorem. But before we begin, if you are new here and you haven't subscribed to my channel, then please subscribe to my channel and hit the bell icon for more notifications. Okay, so we were studying Ceva's theorem. So if you haven't watched the first video of Ceva's theorem, then I'd suggest you to go and watch the first video and then come back again. I post the link in the description below. So now we can begin. Okay, we'll be studying some applications of Ceva's theorem both in the field of Olympiad and in JEE. In JEE, we'll be doing one problem from solution of triangles and we'll be using Ceva's theorem in that question. So stay tuned and watch this video till the end. Okay, now application of Ceva's theorem. So the first application is, it is somewhat a direct application, right? Proving that medians first and second angle bisectors of a triangle are concurrent inside the triangle. Okay, so for medians it is quite simple. Okay, for medians we know that BD and CD, the length is equal. Also CE is equal to AE and AF is equal to FB. Here AF is equal to FB. So that makes BD upon DC equals 1. Similarly, CE upon EA and AF upon FB both are equal to 1. And we can easily see that if we multiply all three equations, we'll get BD upon DC into CE upon EA into AF upon FB equals 1, which was the result of the Ceva's theorem, right? This was the result. So, and we already know the Cevians are the line which are from the vertices of a triangle and concurrent inside the triangle. That was the definition of Cevians, right? So if you guys don't know it, you know it now. So that makes AD, BE and CF, which were medians, that makes it Cevians. And we know that Cevians are concurrent inside the triangle. So that concludes our first theorem. Okay, moving on to the second theorem, angle bisectors. Those who don't know the angle bisector theorem, let me clear it to you guys first. In any triangle, if AD is the bisector, you see AD here. If AD here is the bisector, then BD ratio DC, BD which is this length, BD ratio DC equals AB ratio AC. See, it's so simple. Similarly, for C, we'll have the length BC and for AE, AB. So CE upon EA equals BC upon BA or AB. Similarly, AF upon FB, AF upon FB is equals to AC upon CB. Okay. Again, if we multiply all three equations, we get BD ratio CD, CE ratio EA and AF ratio FB equals 1, which again concludes the result of Ceva's theorem. So again, AD, BE and CF, they become Cevians and hence concurrent inside the triangle. Okay. So now moving on to the one problem from solution of triangles. Now this is somewhat an advanced problem for those who are still in 9th or 10th, right? So, but don't worry, I'll be stating the basics that you need to prove this theorem, okay? And it won't be difficult. Okay, so in triangle ABC, AD, BE and CF are any three lines concurrent inside the triangle at P. See, concurrent inside the triangle, that's our cue. That Ceva's theorem can be used here. So we need to prove that sine angle BAD upon sine angle CAD, sine angle CBE upon sine angle ABE, sine angle ACF and sine angle BCF, the product is 1. Okay. So first understand, I have used some notations for angle BAD. I've replaced it with theta 1, CAD theta 2. So that makes our statement somewhat like sine theta 1 upon sine theta 2, sine theta 3 upon theta 4, and theta 5 upon theta 6 equals 1. We need to prove this. Okay. So before we prove, here are the basics. The basic is sine rule. So all who are in 11th or 12th grade, okay, they already know about the sine rule. It is very simple. Okay. So according to sine rule, A upon sine A is equals to B upon sine B equals to C upon sine C is equals to 2r, or twice of circumradius. Okay. So for angle A, the side which we are taking is opposite to angle A. For B, the side opposite to angle B, right? So also we can say sin A upon sin B is equals to A upon B or BC upon AC, right? That was the basic. Now, moving on. Observe closely the blue triangle, triangle ABD. Let's say angle ADC is theta. Then angle ABD is pi minus theta. So now in triangle ABD, sin theta 1 upon sin pi minus theta equals BD upon AB. The side opposite to theta 1 and the side opposite to pi minus theta. See? Now again observe in green triangle sin theta 2 upon sin theta equals CD upon AC. Okay. And we know that sin pi minus theta is actually sin theta. So this ratio is actually sin theta 1 upon sin theta, which is equals to BD upon AB. Now divide 1 by 2. Okay. Sin theta gets cancelled. Okay. So we have sin theta 1 upon sin theta 2 equals BD upon DC into AC upon AB. Now this is the result which we are going to observe very closely, right? Okay, so we have sin theta 1 upon sin theta 2. Here for theta 1 and theta 2 we have the opposite side BD ratio DC. Also for theta 1 we have opposite side AC, and for theta 2 the opposite side or the alternate side AB, right? So the ratio is like for theta 1 and theta 2 it is BD upon DC and multiplied with for theta 1 AC and theta 2 AB. Now if I am going to write for theta 3 and theta 4, can you do it before me? You can even pause the video. So we have now sin theta 3 upon sin theta 4. For theta 3 CE and theta 4 AE, which is simple. Also for theta 3 the alternate side is AB, and for theta 4 it is BC. So we have the ratio AB upon BC. And similarly for sin theta 5 and theta 6. Again, can you do it before me? For theta 5 we have AF, and for theta 6 FB. So we have AF upon FB, and the alternate sides BC and AC. So BC upon AC. Okay, so this is what we have written here in equation 5 and 4. Now multiply 3, 4 and 5. We're getting on the left hand side we're getting what we need to prove, and on the right side we're getting the result. Okay, so observe closely now. AC upon AB, AB upon BC, and BC upon AC, the product equals 1. So now we are back to the result of Ceva's theorem, BD ratio CD into CE ratio EA into AF ratio FB, which we have just proved that this equals 1. So the product is 1. That concludes our question. Okay,